This is a video presentation about sketching the graph of a hyperbola, but we shall begin with a hyperbola with center at the origin. Example 1.26. Graph hyperbola with center at the origin and the principal axis is horizontal. Before we can go there, before we can sketch the graph of your hyperbola, we must pay attention to many things. The vertices, the conjugate axis, the transverse axis, so on and so forth, and also the asymptotes. So we must produce those things. So given this equation of your hyperbola with center at the origin, find the following: the vertices, foci, and points of your conjugate axis, okay, the asymptotes. So last video, I spoke about the asymptotes and what is the significance of the asymptotes. We shall not use the latus rectum to help us sketch the graph of your hyperbola. Instead, it's the asymptotes which are going to guide us in sketching the graph. After obtaining the asymptotes, we shall sketch the graph. What do we know about this hyperbola? Well, its center is at the origin. This one already tells us that the principal axis is horizontal. But then again, okay, without that clue, we can tell that the principal axis is horizontal based on the term that comes after your subtraction. So when it's the y squared that comes after subtraction, your principal axis is horizontal. So this is how your hyperbola might look like when the principal axis is horizontal. And the denominator that comes after your subtraction is b squared. So that means b squared is equal to 4. So b is equal to 2. What is the significance of b? What information can we get from b? Your conjugate axis. And together, of course, with the length of your transverse axis, we can produce the asymptotes. That's the significance of your b. Okay, so the other denominator would have to be your a squared. It's 16. It's 16, so the square root of 16 is 4. What else? C squared. What information does C give us? It's the distance of your foci from the center. C squared is equal to, okay, so by now you should know that C squared is equal to A squared plus B squared. So C squared is equal to 20. C is equal to the square root of 20. How do you get the square root of 20? You look for a factor that is a perfect square. Okay, so 4 times 5, the square root of 4 is 2. And then you just leave 5 inside the radical sign. So approximately it is equal to 4.47. What else? How did we know that this is going to be the coordinates of your vertex? Okay, so from the center, and your principal axis is horizontal. So 4 units or 4 steps to the left will give you one vertex. And 4 counts of 4 steps to the right will give you another vertex. So that line segment there is what you call your transverse axis. What about the foci? So we shall use the value of C. Negative 4.47, okay, to the left of your center would be, okay, so you will measure negative 4.47. So it's going to be somewhere here, okay, close to your vertex. And the y coordinate is 0. That's your foci 1. Your foci 2 would be to the right of your center. Also, its length or distance from the center is going to be 4.47. The endpoints of your conjugate axis. We shall use your value for b. So, 2 up will give you one endpoint of your conjugate axis, and 2 down will give you another endpoint of your conjugate axis. The asymptotes. Okay, so the asymptotes are 2 intersecting lines, and what you do, if you're like me, who detests memorizing formulas, so on and so forth, what you can do is you can equate this to 0. Equate this to 0 and solve for y. So your y is going to be y squared, okay? This is 0. Transposition y squared over 4 is equal to x squared over 16. Solve for y. Get the square root. It will give you 2 values for y. And y is equal to 1/2 times x. And the other one is going to be y is equal to negative 1/2 times x. So when you say asymptotes, you will produce a line. And in particular, you will produce the equations of those 2 lines. We shall now go to sketching the graph of our hyperbola. Okay, so that is our center. The 2 vertices, the 2 foci, the endpoints of your conjugate axis. So again, what we do is your conjugate axis and the transverse axis produces a rectangle. There is a rectangle here. Let us show that. Okay, so we shall show that rectangle. Okay, so what you can do is you can just draw a perpendicular line through the vertex and another one through the second vertex and draw a horizontal line through the 2 endpoints of your conjugate axis. It will form a rectangle. Why do we do this? Because the corners, the opposite non-adjacent corners of your rectangle, the line through those corners, is actually the graph of your asymptotes. And so this is what we're going to do. We know how the hyperbola behaves in relation to the asymptote. The branches of our hyperbola will get closer and closer to your asymptotes. That is what's going to happen. What you will do now is, starting from the vertex, you will just trace the arms of your hyperbola. Okay, so the same with the left branch of your hyperbola. You will trace the arms of your hyperbola. So I will show it now. So that is our hyperbola. But then again, these things, the rectangle, the asymptotes, they are not part of your hyperbola. They are not. But the characteristics of your hyperbola is shaped by these things. So I will now remove this clutter. I will just show to you the graph of our hyperbola. So that's it.